Now coming to the thermosetting polymers. Actually the current went off, so hence I have to stop in middle. Thermosetting polymers. The polymers which on heating change irreversibly into hard, rigid and infusible material are called thermosetting polymers. Again I repeat, the polymers which on heating change irreversibly into hard, rigid and infusible materials are called thermosetting polymers, so to say. So the three-dimensional network structure is rigid. Actually, why it is hard? It is because the three-dimensional network structure is rigid, it is hard, and it does not become soft on heating. Alright, it does not become soft. So some important examples of thermosetting polymers are phenol, formaldehyde, resins, melamine formaldehyde resins, urea formaldehyde resins, we can say that. Actually, thermosetting polymers on heating, they become infusible and they form an insoluble hard mass. Like thermoplastics, on heating they become soft. But thermosetting polymers on heating they become hard and it becomes infusible. Example I can give it to you, a very simple example. You have seen a water bottle, isn't it? The bottle which you are using in a house for drinking water, isn't it? You are keeping in the refrigerator. You have seen the bottle is nothing but a thermosetting polymers, thermoplastics, the bottle is. But the cap of the bottle, which is hard, we can say that it is nothing but coming under thermosetting polymers. The cap of the bottle is coming under thermosetting polymers, but the entire bottle is coming under what you can say thermoplastics, we can say that. So we are adding in thermoplastics, you have seen it, we are adding plasticizers, we are adding it. So when the plasticizers is being added, the workability of the thermoplastics at relatively lower temperature can be increased, alright, by addition of thermoplastics, you can say that. So what is the effect of structure and the what you can say on the properties of the polymer is that the plastic deformation takes place. The plastic deformation, that is, when the thermoplastic is subjected to heat, it gets deformed. You can see the bottle is of different shapes, we can say that, different shapes. Some are round, some are cylindrical, some are conical, this, that, different shapes of the bottle you are getting it. In the middle also there is some shape, in the middle it is bulged, in the end it is tapered, you can see that, clear. This property of thermoplastics is known as plastic deformation. Again I repeat, when a thermoplastic is subjected to heat, it gets deformed, the change is there is a change in shape. So the property of thermoplastics is known as plastic deformation, we can say that. So the other effects of the structure and the properties of the polymer is that we have seen it, the molecular mass and the degree of polymerization. We have seen the intermolecular forces of attraction, that is your elastomers, fibers and all. We have seen the shape of the polymer molecule, that is slipping power of the polymer molecule, we can say that. Alright, we have seen the type of polymerization, the state growth, the chain growth, the different types of polymerization, we have seen it, clear. We have also seen the co-polymerization, with copolymer we can say that, where two or more monomers combines to form a polymer, we have seen it. So all these things we have seen it. Now we will come to some commercially important polymers. Basically the questions you will be getting from this area only, which I am going to tell you now. Alright, you will be given a particular name of a polymer, and you will be asked what is the type of polymer, which you have studied already earlier. Alright, what are the monomers which are involved in it, what are the properties of this particular polymer. So you need to go through it, all these things. That is the examples, rather I should say, upon polymerization, which I am going to say you now. So I am going to tell you some few examples upon it. Got it? Upon the different types of the polymers like chain growth, step growth, addition, condensation, the different types of polymerization process we have done it. So coming to the first is your addition polymerization. Alright, addition polymerization, and addition polymers, rather I should say, that is your addition polymers, I should say. So under addition polymers we are having polyethylene, we are having polypropylene. Now here we also get the short forms which may come in your exams, and you will be asked to write the long form of it. Like polyethylene, it is written as PE. Polypropylene is written as PP, we can say that. Polystyrene, it is written as styron, 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 we can say that, polystyrene. We are also having neoprene, which is a synthetic rubber. We can say that the neoprene, the synthetic rubber. We are also having Buna-S, which is also written as SBR. Got it? Buna-S, which is written as SBR. Got it? We are also having, that is PMMA, polyethyl methacrylate. So you will be getting the short form also. You may get the short form also. So you should be prepared for everything. Understood? That is what I mean to say. You should prepare for everything. The question may come from any area. We can say that. So hence, but one question generally we see it comes from this particular area every year in the board exams and in the entrance part also we see it. Alright. So in polypropylene, it is one of the most common plastics. We know that it is prepared with the addition of polymerization of ethene. We have seen already the reaction. Already we have seen it. So polyethylene is of two types. We have got LDP, low density polyethylene, and we have got HDP, high density polyethylene. We can say that. LDP and HDP. That is your, what I said, LDP and HDP. LDP is low density polyethylene and HDP is high density polyethylene. So the difference is that in LDP, what happens is that first we'll see LDP, N molecules of ethene, CH2 double bond CH2. The condition is only going to differ. Got it? In LDP and HDP. This is the reaction which I am writing it for HDP, so to say. That is N molecule of CH2 double bond CH2. Got it? N molecules. In both the cases, we are taking N molecules of ethene. Now in LDP, the pressure will be 1000 to 5000 atm and 520 Kelvin. 1000 to 5000 atm and around 520 Kelvin. We can say that 520 Kelvin and oxygen. What you will be getting? You will be getting polyethylene LDP. That is CH2 whole N. Alright. This is your LDP. We got it. Single bond CH2 whole N. Now next is in HDP. What is that? The temperature will be the pressure will be 6 to 7 atm. And around 330 Kelvin. See, pressure is reduced and temperature is also being reduced. We can say that. Got it? So 330 to 430 also we can say that. We can also write from 330 to 430 Kelvin. We can say that. Got it? And in presence of a catalyst that is known as Ziegler-Natta catalyst. Ziegler-Natta catalyst. A type of catalyst. It is being used. You have read it, this one in what you can say. Which chapter that one is coordination compounds. Got it? You have read it. Also you have studied in class 11 in Grignard reagents. That is organometallic compounds. You have studied about it. That is Ziegler-Natta catalyst. We can say that. So it's a type of catalyst which is being used. What you will be getting? Same product. Product is the same. CH2 whole N. It's only the conditions is differing. So hence we get LDP and HDP, so to say. Alright. So in this way. These are the two types of polymers. In case of polyethylene, we can say that. In case of polypropylene, what you need to do is that you need to take a propene, and in presence of Ziegler-Natta catalyst, you will be getting polypropylene. N molecules of propene in presence of Ziegler-Natta catalyst will give you polypropylene. We can say that. Clear? N molecules of propene if you take it. Then in case of polystyrene or styron, we can say that you will be taking styrene. Styrene is what? Benzene ring CH double bond CH2. N molecules, you will take it. N molecules of benzene ring CH, first position CH double bond CH2. In presence of catalyst, any catalyst you can take it here, it will be your polystyrene. The formula polystyrene is the double bond, you are going to open it. It's very simple, in addition polymerization, you need to open the double bond CH, that is CH2 whole N. So here what you find is the carbon is satisfied. You can see the carbon is satisfied here. Here also the carbon is satisfied. You can see. So this is known as polystyrene or said to be as styron. So if you take N molecules of styrene, then you will be getting it. So that is neoprene. It is a polymer of what you can say, chloroprene. We can say that. So already chloroprene I have said you 2-chlorobuta-1,3-diene, which is nothing but a synthetic rubber. Alright. So what you will do is that you will take 2-chlorobuta-1,3-diene in presence of peroxide. If you take, then you will be getting, that is neoprene. 2-chloro, second position chloro, buta-1,3-diene. Alright, butane, first and third position in double bond will be there. So if you take N molecules, always you take N molecules. The reactant will be N molecules. It will be written here N, and in the product the N is written here. Alright, it will break up the chain. So what you will be getting? You will be getting, that is nothing but neoprene. Let me write the reaction, that is better. Let me write. So that is chloroprene will give you what I said, N molecules of diene 2-chloro. Here it is CH2. Here it is, okay, fine, it is CH and here it is CH2. So here there is 2-chloro. This is your 2-chloro-buta-1,3-diene. In presence of peroxide, you will take peroxide in presence of. So what you are going to do is that you are going to open up. Double bond you will open up. So that means you will put here CH2, then here C, single bond Cl, then here CH, then again CH2, single bond whole end. Now you need to balance it. So here carbon is satisfied. Here you will put a double bond. Then only this carbon will be satisfied. Here also this carbon will be satisfied and whole end. This is your nothing but known as neoprene, which is your artificial rubber. We can say that. Similarly, you can prepare Buna-S. Buna, B-U-N-A, butane nitrile. We can say that. So SBR means styrene butadiene rubber. Buna-S is also called as SBR, styrene butadiene rubber. So you will take buta-1,3-diene. Alright, buta-1,3-diene, no chlorine will be there. Buta-1,3-diene you will be taking it, and you will take styrene. N molecules of styrene and N molecules of buta-1,3-diene in presence of peroxide and 273 Kelvin. So what you will be getting is that you will be getting, that is nothing but Buna-S, that is SBR, that is styrene butadiene rubber. You will be getting it. Alright. So in this way you can prepare, that is Buna-S. Let me write the reaction Buna-S, it will be better. That is SBR, styrene, and Buna you need to write in this way. B-U-N-A, Buna-S, we can say that. So styrene butadiene rubber, we can say. So Bu stands for butadiene and Na stands for what you can say, nothing but that is sodium, we can say. Clear? So now for the symbol sodium. Clear? So which is the polymerizing agent? That is SBR. So what I said, you will take N molecules of butadiene, buta-1,3-diene, CH2, then CH, then CH, double bond CH2, plus N molecules of styrene, CH, double bond CH2, in presence of, that is, I've said you already, 273 Kelvin and peroxide. You'll be writing it out here, 273 Kelvin and peroxide. And you can take a little bit of emulsion also, a particular emulsion you can take, any emulsion, oil in water or water in oil emulsion, you can take it. So what will happen is that you will be getting this reaction. I've written it earlier also, this reaction. So you will be getting, that is nothing but Buna-S. So this CH, CH2, H will be here. H will be here, CH2, whole N, then this C. Alright, so here it will be nothing but CH2, this bond will be there, then it will be here CH, then CH, then CH2. Now we need to balance it. Here the double bond will put it here, then only it will be balanced. Here already it is being balanced, we can say that. So this is nothing but your SBR, styrene butadiene rubber. Then we can get polymethyl methacrylate, that is PMMA. So where you will be taking, that is methyl methacrylate. Let me write the reaction. It's also coming under addition reaction, don't worry. It is coming under addition reactions only. PMMA, polymethyl methacrylate, we can say that. PMMA, polymethyl methacrylate, so to say. So here, that is, I will be taking N molecules of methyl methacrylate, that is N molecules of CH2, C, CH3, COO, CH3. So here it will be CH, rather I should say. So that is CH2, sorry, CH2, no, CH will be there, double bond will be there, sorry. So C, then CH3, COO, CH3, we can say that. This is your methyl methacrylate, we can say. So in presence of peroxide, So it's very easy to write the polymerization reaction because double bond will break up, will come here. Alright, double bond will break up and it will come here. Then it will be your CH3 and one bond will be here and COO CH3 whole end. So one bond will be added here and one will be added here in this way. So this is nothing but is your polymethyl methacrylate. You can bring COOCH3 here and you can bring this bond here also. No problem. Nothing big. So in this way you can also prepare polyacrylonitrile, that is known as acrylan. Acrylan is what? You will take acrylonitrile, N molecules of CH2 double bond CHCN. N molecules of CH2 double bond CHCN, that is your vinyl cyanide. You will take N molecules of vinyl cyanide. In presence of polymerization will give you, that is single bond CH2, single bond CH, single bond, then below CH you will write CN, whole N. Again I repeat, single bond CH2, single bond CH, then you will put a single bond and below CH you will put single bond CN, whole N. That is nothing but acrylan, we can say that. Got it? So it is also known as PAN, PAN, polyacrylonitrile. In short, it is said to be as. Then we can prepare PTFE, polytetrafluoroethylene. You will take tetrafluoroethylene, that is N molecules of CF2 double bond CF2. Alright, in presence of high pressure and oxygen will give you single bond CF2, single bond CF2, single bond whole N. What I said, N molecules of CF2 double bond CF2. Very easy it is. In presence of high pressure, it will undergo polymerization to give single bond CF2, single bond CF2, whole N. We can say that. This is called as Teflon or PTFE, polytetrafluoroethylene. In presence of high pressure and oxygen, let me write it this also. High pressure and oxygen will give you PTFE, polytetrafluoroethylene. We can say that. Clear? So we can also get PCTFE, polychlorotetrafluoroethylene. So in that case, one fluorine will be replaced by chlorine. It will be CClF2 double bond CF2. We can say that. CClF double bond CF2. Alright. So PCTFE, we can say that. So you will be getting, that is nothing but polychlorotetrafluoroethylene. So next is polyvinyl chloride. That's PVC. It's very common. This one is, you will take N molecules of vinyl chloride, you will be getting PVC, that is polyvinyl chloride. So all these was coming under addition polymerization, we can say that. Addition polymerization. Now we will come to, that is your condensation polymerization. Condensation. So under condensation polymerization we can prepare, that is your terylene or dacron, we can prepare glyptal, we can prepare nylon 6,6, we can prepare nylon 6,10, we can prepare nylon 6, so many we can prepare it. Under condensation polymers we can also prepare, that is your nothing but formaldehyde resins, phenol formaldehyde resins, melamine formaldehyde resins, we can prepare it. So let us start. That is nothing but condensation polymerization, we can say that. Condensation polymerization. Condensation polymerization, we can say. So in condensation polymerization, the polymers having ester linkages are known as what? Polyesters. First of all, you need to understand. The polymers, those who have ester linkages, they are called as polyesters. Ester means COO linkages, whichever the polymers is having. They are called as polyesters. Polyesters we call it as. Now I am going to show you the preparation of terylene or dacron, we can say that. So for that purpose you have to take ethylene glycol and you have to take terephthalic acid. Ethylene glycol N molecule and terephthalic acid. So N molecule of HOCH2CH2OH plus N molecule of terephthalic acid. Terephthalic acid is HOOC, benzene ring, then COOH. Got it? What will happen is that I have said you earlier also that here HO will be removed. Here that is nothing but HO, or you can take here that is nothing but HO from here, and you can take H from here. We can just say that. Clear? As you wish. Here also same thing, HO, and here H will be removed from here. So what you will be getting the product? See, 2 N molecules of water is eliminated. 2 N molecules of water. This is N molecules of water. This is OH, H, N molecules. 2 N molecules, so what is eliminated? And what you get the product? The product is CH2, CH2, then that is, here it is, you will be getting O, this oxygen, then CO, then benzene ring, then COO whole N. This is otherwise called as terylene or dacron. We can say that. This is known as terylene or dacron, we can say. Okay, fine. So in this way you can prepare, that is terylene or dacron. Now you can do one thing, you can put this here. If you take H here, so you will be getting O here. OCH2, CH2, CH2, and this O will not be there. It's up to you. It's up to you. This O will be shifting here. If you take H here, mind it, H here, so it will be OCH2, CH2, CH2. So then this O will not be there. So if you take H here, then you will be taking OH here. Isn't it clear? So in this way it will be done. So next is nylon 66. Already we have done it. We have seen it, nylon 66. In difference between nylon 66 and nylon 610 is there. In 66 we have got 6 carbon atom. Both the monomers have got 6 carbon atoms. And in 610, one monomer has got 6 carbon atom, other monomer has got 10 carbon atoms. That is, one is your hexamethylene diamine, hexamethylene, so 6 carbon atom. Another is your sebacic acid. Sebacic acid is HOOC, single bond CH2 whole 8, HOOC. Alright, HOOC, single bond CH2 whole 8, then COOH. So total 10 carbon atoms. Sebacic acid. So it is known as nylon 610. We will give you nylon 610, so to say. Thank you.